In 2013, Boeing stood in front of the world's airlines and promised something simple: a bigger, more efficient version of its best-selling wide-body jet, ready to fly passengers by 2020. That promise is still not fully kept. What was supposed to be, by Boeing's own early description, a relatively straightforward upgrade to an already successful aircraft, has instead become one of the most delayed commercial aircraft programs in modern aviation history, pushed back year after year through engine problems, a global pandemic, structural test failures, and a level of regulatory scrutiny the aviation industry hadn't seen in decades. Airlines that ordered the aircraft expecting to fly it years ago are still waiting. This is the history of the Boeing 777X. To understand why Boeing built the 777X, you first have to understand just how successful the original 777 had been. Introduced in 1995, the 777 became one of the most commercially successful wide-body aircraft ever built, prized by airlines for its combination of long-range, respectable fuel efficiency and the flexibility to serve a wide range of international routes profitably. It was, for the better part of 2 decades, the aircraft airlines reached for when they needed to move large numbers of passengers efficiently across oceans and continents, and Boeing sold thousands of them across multiple variants, tailored to different route lengths and passenger capacities. But by the early 2000s, the 777 was facing a genuine competitive threat. Airbus had introduced the A350, a newer wide-body built with more modern materials, including a far higher proportion of lightweight composite structure than the original 777's largely aluminum airframe, and more efficient engine technology, offering airlines meaningfully better fuel efficiency than Boeing's aging 777 design could match. For airlines operating on razor-thin margins over the life of an aircraft that might fly for 2 or 3 decades, that kind of efficiency gap wasn't a minor consideration. It was potentially the difference between a profitable route and a money-losing one. Boeing needed an answer, and rather than starting from scratch with an entirely new airframe, the way it had with its smaller 787 Dreamliner a few years earlier, the company chose an approach it had used successfully before: take the proven 777 fuselage and re-engineer it with dramatically more efficient engines, new composite wings, and a range of aerodynamic improvements, creating what Boeing marketed as the 777X, split into 2 variants, the smaller 777-8 and the larger 777-9. The strategy carried real appeal. Keep the parts of the 777 that airlines already trusted and knew how to operate and maintain, while updating exactly the components that mattered most for competing with Airbus's newer design. At the heart of the 777X's promised efficiency gains was an entirely new engine, developed specifically for this aircraft, the GE9X, built by General Electric, and at the time of its unveiling, the largest jet engine ever constructed for a commercial aircraft, with a fan diameter wider than the fuselage of some smaller airliners, and wide enough that it became something of a spectacle in its own right at aerospace industry events, a genuine engineering marvel that generated headlines, independent of the aircraft it was built to power. The engine wasn't the only major departure from the original 777. Boeing also gave the 777X folding wingtips, a genuinely novel engineering solution to a very specific airport problem. The new, longer composite wings were more aerodynamically efficient in flight, extending well beyond the wingspan of the original 777, but too wide to fit within existing airport gate space, designed around the original aircraft's dimensions that had themselves shaped decades of airport terminal planning worldwide. Rather than accepting a less efficient, shorter wing, or requiring airports worldwide to rebuild their gate infrastructure at enormous collective cost, Boeing engineered wingtips that mechanically fold upward on the ground after landing, narrowing the aircraft's footprint enough to fit existing gates, then unfold automatically before takeoff. It was an elegant solution to a real problem, and also, as it would later turn out, one more entirely new mechanical system that had never before been certified on a commercial passenger aircraft, adding yet another first-of-its-kind element to a program that would ultimately accumulate far more of them than Boeing initially expected. When Boeing formally launched the 777X program in 2013, airlines responded with genuine enthusiasm. Emirates, the aircraft's eventual largest customer, placed a massive order, alongside commitments from several other major international carriers, drawn by the promise of meaningfully lower operating costs on the exact long-haul routes that mattered most to their businesses. The order book for the 777X, in fact, was widely reported at the time as one of the largest and most valuable wide-body launch order tallies in Boeing's history, a strong early vote of confidence from an industry that had, at that point, no particular reason to expect anything other than a smooth continuation of the original 777's successful track record. The original plan called for the 777X to enter commercial service in 2020, a target that, in hindsight, assumed a level of smoothness that almost no clean-sheet aircraft program, let alone one built around entirely new engines and a first-of-its-kind folding wing mechanism, has ever actually achieved. The first cracks in that optimistic timeline appeared even before the aircraft's first flight, as GE encountered its own development challenges, getting the enormous new GE 9X engine through its own testing and certification process on schedule. Problems that included durability concerns discovered during early engine testing that required additional design refinement before the engine could be considered mature enough to support the broader aircraft program's own certification timeline. Just as the 777X program was working through its early development challenges, Boeing found itself consumed by a far larger, far more damaging crisis entirely unrelated to the wide-body program: the grounding of the 737 MAX following 2 fatal crashes, and the subsequent, intense regulatory scrutiny that followed. The 737 MAX crisis didn't just damage Boeing's reputation and finances, though it did plenty of both, costing the company billions of dollars and severely denting airline and public trust in the Boeing name at exactly the moment the 777X needed that trust to help smooth its own path through development. It fundamentally changed how the FAA approached certifying every Boeing aircraft going forward, including the 777X. Regulators, having faced intense public criticism for what many viewed as an overly cooperative, insufficiently independent certification process with Boeing on the MAX, adopted a significantly more rigorous, more hands-on approach to reviewing the 777X's certification, a shift that, while arguably necessary and appropriate given what had just happened, also meaningfully extended the 777X's own timeline, well beyond what engineering progress alone would have required. Boeing engineers reportedly found themselves resubmitting documentation and undergoing additional review steps that simply hadn't been part of the original certification roadmap when the program launched back in 2013. In 2020, during a structural stress test intended to push a 777X test airframe to the edge of its design limits and beyond, as is standard practice for certifying any new aircraft structure, the aircraft suffered a structural failure, with the fuselage rupturing under the extreme applied load. While this kind of destructive testing to failure is, in a sense, exactly what these tests are designed to eventually produce, since engineers need to know precisely where a structure's true limits lie, the specific nature and circumstances of this particular failure raised concerns that required additional investigation, design review, and retesting, adding further delay to an already slipping schedule. The incident became public knowledge and drew renewed scrutiny to the program at a moment when Boeing could least afford another headline suggesting problems with its engineering or testing processes. given how closely the aviation world and aviation regulators were already watching the company in the aftermath of the MAX crisis. Combined with the pandemic's devastating impact on global air travel demand throughout 2020 and 2021, which sharply reduced the urgency airlines felt to receive new long-haul aircraft, they suddenly had far less need to fly, since entire long-haul fleets sat parked for months with international borders closed. The 777X program's original 2020 target slipped further and further into the future, first to 2021, then 2022, then beyond, each new delay compounding the last. Through the early and mid-2020s, Boeing repeatedly pushed the 777X's entry into service date back, each new announcement citing a mix of ongoing certification requirements, continued engine refinement, and the broader pressure the company remained under to demonstrate, beyond any doubt, that it had genuinely overhauled its safety and quality processes following the MAX crisis. Each fresh delay announcement followed a familiar, uncomfortable pattern for Boeing: a brief statement citing continued progress, alongside an updated, later timeline, followed by renewed skepticism from industry analysts and airline customers, who had, by that point, heard similar reassurances more than once before. For the airlines waiting on their orders, particularly Emirates, whose long-term fleet planning had been built substantially around the 777X's originally promised capabilities and timeline, the repeated delays created genuine operational headaches, forcing carriers to extend the service life of older aircraft well beyond their originally planned retirement dates, adjust route planning around aircraft that were never meant to still be flying at this point, and publicly express frustration with Boeing's inability to deliver a firm, reliable timeline. Emirates' own leadership became known for unusually blunt public criticism of the delays, a level of public frustration from a major customer that is relatively rare in an industry where airlines and manufacturers typically prefer to manage disagreements quietly, out of public view, given how interdependent airlines and manufacturers remain across decades of ongoing aircraft orders, deliveries, and support relationships. Emirates' president, in various public appearances and interviews over the years of delay, openly voiced skepticism about Boeing's revised timelines, at times suggesting the airline had grown weary of receiving updated delivery estimates only to watch them slip again. That kind of public friction matters beyond simple embarrassment for Boeing, since Emirates represents by far the largest single 777X order on the books, and any serious erosion of confidence from a customer of that scale carries real weight in an industry built substantially on long-term trust between a handful of major manufacturers and a relatively small number of enormous airline customers, capable of placing orders in the hundreds. By the time the 777X finally moves toward genuine commercial service, the program will have taken not the 7 years Boeing originally promised in 2013, but closer to 15, an extraordinarily long gestation period, even by the standards of an industry notorious for ambitious original timelines, slipping significantly in practice, and roughly 3 times longer than the development period Boeing itself originally projected when the program launched. That extended timeline hasn't been without any benefit at all. The additional years of testing, redesign, and regulatory scrutiny have, by most accounts, resulted in a more thoroughly vetted aircraft than the one Boeing might have delivered on its original, more aggressive schedule. Precisely the kind of extra caution regulators insisted on in the aftermath of the MAX crisis, and precisely the kind of caution that a company still working to rebuild public and regulatory trust arguably needed to demonstrate, regardless of the commercial cost. But it has also meant Airbus's competing A350 has had over a decade of uncontested market presence on exactly the routes the 777X was designed to contest, winning orders from airlines that might otherwise have waited for Boeing's answer, a competitive cost that doesn't show up on any single delay announcement, but compounds quietly, order by order, year after year, as airlines making fleet decisions today simply cannot wait indefinitely for a program with a track record of missed deadlines. Despite everything the program has been through, the underlying case for the 777X hasn't disappeared. Airlines that ordered it did so because the fundamental efficiency improvements, the larger, more efficient GE9X engines, and the aerodynamically superior composite wing still represent a genuine, meaningful step forward over the aircraft it's replacing, regardless of how long it's taken to actually arrive. Once in service, the 777-9 variant is expected to offer airlines a larger passenger capacity than the original 777-300ER. It succeeds, combined with substantially improved fuel efficiency per seat, numbers that matter enormously to airlines operating on long-haul routes where fuel represents one of the single largest ongoing operating costs across an aircraft's decades-long service life. For an airline like Emirates, with a business model built heavily around large capacity, long-haul international connections through its Dubai hub, those efficiency gains, even arriving years later than promised, still represent a substantial competitive advantage once the aircraft is finally flying revenue routes at scale. Somewhere in a Boeing facility, engineers are still working through the final steps towards certifying an aircraft that airlines were originally promised well over a decade ago. An aircraft whose folding wingtips and record-setting engines once represented the confident, straightforward next step in a decades-long aviation success story. It hasn't turned out to be straightforward at all. Between an engine that took longer to mature than planned, a company-wide crisis that reshaped how regulators would scrutinize everything Boeing built afterward, a structural test failure that demanded its own investigation, a pandemic that removed any urgency to rush the process, and a major customer that grew increasingly public about its frustration, the 777X became less a simple upgrade and more a decade-and-a-half-long lesson in exactly how much can go sideways between an ambitious announcement and an aircraft actually, finally, carrying its first paying passengers. A reminder that in commercial aviation, even the most proven, most successful manufacturer in the world isn't immune to a program simply taking far, far longer than anyone standing on that stage in 2013 ever expected.